Hi, this is Greg from Newton, and right now we're going to look at, it's a pretty particular case of a radical function composed with a rational function. So here we have a rational function that is within a radical. Now, there's a couple particular things about this domain. Because of the rational function in here, we could have undefined values. So anything that would make the denominator equal to 0 would make this function undefined. Also, anything inside the radicand that is less than 0 would also make this function undefined. So what we have to do is, first, we'll find the domain of the radicand, the thing inside this radical. And then what we're going to do is see when is this rational expression less than and when is it greater than 0. So x squared plus x minus 6 over x minus 4. All I have to do is set the denominator equal to 0. So I know that x cannot equal 4. That's the first thing in this domain, x cannot equal 4. Now, this is not the graph of this rational function, this rational expression, but I just wanted to show what's going on here. Notice the places that a rational function can switch signs. It can go from being positive to negative at an x-intercept. So it happens here, and it happens here. Both times it goes from being positive to negative, or from negative to positive. And then also, around this asymptote, it's negative here, and it doesn't have an intercept, but on the other side of the asymptote, now it's positive. So the places that I need to check are both the intercepts and at the asymptote. So I know I have to check x equals 4, and then my intercepts would be any time that my numerator equals 0. This is a quadratic, and so I can factor this to see where the numerator will equal 0. So the places that the numerator will equal 0, my intercepts will be at x equals negative 3 and at x equals 2. So I have 3 places to check. X equals negative 3, x equals 2, and x equals 4 are the places where the rational function could switch signs. Again, the reason we're doing this is because we need to find where is this expression negative. When the expression inside here is negative, then the domain will be undefined. So what I'm going to do is I'm going to make a little chart here. Negative 3, 2, and 4. Because I know it's either 0 or undefined here. And I'm going to see what happens on every side of each of these values. So if I'm less than negative 3, let's plug something that's less than negative 3 into this expression and see if it's negative or positive. So I'll choose negative 4. Negative 4 plus 3 times negative 4 minus 2, or negative 4 minus 4. Negative 4 plus 3 is negative. Negative 4 minus 2 is negative. And negative 4 minus 4 is also negative. A negative times a negative will be a positive. And then this is negative. And a positive divided by a negative will be a negative. So if I'm on the left side of negative 3, my function, or this rational expression, will be negative. And so I know that this cannot be a part of the domain. Now let's check something in between negative 3 and 2. Typically, the easiest thing to check is 0. So again, I've got my rational expression, x plus 3. And it's easiest to keep this in factored form, I think. 0 plus 3 is a positive number. 0 minus 2 is a negative number. And 0 minus 4 is a negative number. Positive times negative is negative. Negative divided by a negative will be positive. So in between negative 3 and 2 is positive, and that will be allowed to be part of my domain. Now again, check in between these values. So something between 2 and 4. I could pick any number I wanted, but it's always easiest to pick, nice easy numbers. So I'll pick 3. So here's my expression again. what happens? 3 plus 3 is positive, 3 minus 2 is positive, 3 minus 4 is negative, positive times positive is positive, positive divided by negative will be negative, so this will not be part of my domain. And finally, anything greater than 4, I'll test that. So something greater than 4, let's say 5. 5 plus 3 is positive, 5 minus 2 is positive, 5 minus 4 is positive, everything's positive, so that'll be positive. So in between negative 3 and 2, and also because the square root of 0 is defined, and negative 3 and 2, it exists here, I'm allowed to use those values. So if I'm writing this in interval notation, I would use a bracket and say from negative 3 to 2 is allowed, and then anything greater than 4. Now again, I have to check my original. X cannot be 4 because of the denominator here. So the 4 would not be included. So negative 3 to 2 in brackets, along with union, parenthesis, 4, and then anything bigger than 4 is fine. So 4 to infinity, and infinity you're always going to use a parenthesis. So again, we're finding the domain of the rational expression that's inside the radical, and then finding where is this radical positive, or sorry, where is the rational expression positive, and that's where my domain is going to be true.